Alright, so hopefully you're coming back to this second video because that last one wasn't horribly boring and irritating. Or at the very least, you're willing to work through it, and my voice is not the worst thing in the universe. Anyway, let's learn about probability and significance. So what are we talking about in probability and significance? Remember that we're only going to gather data from a sample of people. And so if we sample a certain number of people, we need to use likelihoods or probabilities to see if we can make statements about everyone. Plus, we have a different sort of problem. Consider this. We know that most boys are taller than most girls, or maybe a better way to say that is that boys are, on average, taller than girls. However, there's a problem here. Some girls are taller than some boys. So can we really say that boys are on average taller than girls? What can we do about this? Well, there are some things that we can consider. We've talked about confounding variables, like the age of the boys. Girls and boys have different rates of growth at different ages. So at certain ages, girls tend to be slightly taller than boys, actually. But on average, as adults, men and women tend to have that relationship where men tend to be slightly taller than women, as long as you keep all things equal, like age and race. So what can we do about the fact that this data is muddy? The fact that some women and some girls are taller than some men or some boys? Well, when we work with statistics, we can overcome those problems using probability, and we'll actually see how this can help us overcome the problem of sampling. So let's say that most boys are about a half foot taller than most girls. And we've got a number line here on the bottom of the screen showing roughly that. We can say that here we have kind of a graph showing on average here, the average or most boys is here in the middle, about half a foot taller than most girls. So here we have the difference in height between boys and girls, and we know that most people, most boys are going to be taller than most girls, shown here the majority of people. But some people have that problem, not problem, sorry, some of our data has the problem that girls are taller than boys. So our question doesn't have a perfectly clear-cut answer. If some girls are taller than some boys, how can we say that on average, or just generally, boys are taller than girls? Well, we can use statistics to say that there is a significant difference in the height of boys and girls. A significant result is something that we use in psychology and in statistics generally, science generally, to say that overall we know something about our data. So there's a lot that you can learn about statistics, but to simplify things down, we have this idea that we're never going to be 100% certain about anything we say. But if we're at least 95% sure that boys are generally taller than girls, we can say that there is a significant difference in the heights of boys versus girls, and that boys are taller. You may remember from previous modules the idea of the null and research hypotheses. This is where those come into play. So if you gather data, you might have an average height for boys of, say, 6 feet, an average height of girls of 5.5 feet, and even though some girls are taller than some boys, you can say that that average difference of half a foot is enough of a difference to be significant under a certain condition. And that certain condition has to do with sample size, which we'll learn in a moment. But how do we describe this information? When we write this information down, we usually say that significant results, or a significant difference, a difference we can be confident in, is represented by this, p less than 0.05, or a number that means that, p equals 0.02. That is less than 0.05. This describes the idea that the confidence we have in the existence of a difference is at least 95% or greater. Where did we get that number, 95%? It's actually kind of arbitrary, but it's a pretty common number to use. So again, a significant result means that we are at least 95% sure that there's a difference in height between boys and girls, or between whatever groups of things you're comparing. And that significant result is described or written out most often as p equals some number, or p less than greater than 0.05. To give you more examples, a researcher may write something like this: there was a difference, or there was a significant difference in height between boys and girls, and put that parenthesis p less than 0.05. But they could also write there was a significant difference, p equals 0.01 in height between boys and girls. And since this is still 0.01, still less than 0.05, that's a significant difference. Here's the alternative. There was no difference in height between boys and girls. So here, this p equals 0.43, that number is bigger than 0.05, so it's not a significant difference as referenced over here. Same thing, it may be written as p greater than 0.05. So they didn't tell us exactly what the confidence we had was, but it's definitely higher than our threshold, so there was no difference. This is a very important thing to understand. And so the activity that will follow this module is just about identifying what do these p numbers mean. Remember, as a conclusion, p stands for probability. It means the confidence we have in there being a difference. This doesn't tell you whether boys or girls are taller, only that we believe there is a difference in height with this amount of probability. Okay, so just to be clear, there is a less than 5% chance we're making a mistake. That's why it's 0.05, not 95%. But does that make sense? I hope it does. Just to say that again, when we say less than 0.05, that means that there is a less than 5% chance that we're making a mistake, or in other words, we have a 95% or greater confidence that there is a difference. All right, I hope that made a lot of sense to you, and if it didn't really, this is actually a very simple thing. You are likely overthinking it. Give the module activity a shot, and if that works out for you, if it makes sense, then feel free to move on.